Okay, so now we're ready to write our first program for the Romi, and you've downloaded Visual Studio Code and Platform I/O, and you see this little alien head down here. And after you've written a program with Visual Studio Code, when you open it, it will open to whatever the last program is that you were working on. So that's why you can see this blue motor. I was working on a blue motor program, but if you want a new window, you can go to this new window like that, and okay, just expanded that window a little bit, and then you can click on the alien head here, and you can see that you can open a new file, or we want to start a new folder. So I'm going to click on Open. And then we're going to create a new project. Okay, so the project name, we could say first Romi program. And now we have to select the board. And so I'm just going to type in 32U4. And this is the board, this is the Pololu A-Star 32U4. And the framework is Arduino, because this basically works as an Arduino. And then we can use the default location. If I hover over that, you can see that by default, it's just going to put it in your documents folder in a subfolder called Platform I/O and a subfolder called Projects. But you can uncheck that and then select any folder you want. I'm just going to leave it at the default for now, and then just click Finish. And this, especially the first time, it may take a while to finish loading. So just be patient, wait for it to, as it says, please wait. Okay, so now you can see it's finished loading, and there at the top you can see it says first Romi program. And well, what we have to do now is if we go to this platform INI file, right, you can see that it's put in the A-Star 32U4, the platform, the kind of board, the framework we're going to use, but we also have to tell it where the libraries are. So to do that, I'm going to go back to a program I had already created, the Blue Motor program, and go to that platform.ini, and you can see that after the framework equals Arduino, there's these other three lines. So I'm just going to copy those, and you do need to do this exactly like this with the white space, same kind of white space. So I'm just going to copy that and then go back to the other file and just paste that in place. So you want to add these three lines just the way they are, and this then tells the software, where the libraries are. Okay, so now that we have that, we're going to go to this right here, and you'll see that there's a main.cpp there. And so this should look familiar with what you did with the ESP32 for your homework problems, programming homework problems in RBE 1001. You can see that you have the setup, and those programs are just run once at the start, and then loop. So that code the loop just repeats over and over again. And by default, it puts in include arduino.h is the header file for the different functions and whatnot from Arduino. But we're going to replace this with include Romi 32U4.h. Okay, so then another thing we're going to do so we can print to the monitor here is in setup, we'll put in serial.begin 9600. Oops. And we have to remember to put the semicolon there. Okay, so the next thing we want to do is create a chassis object. So in the we already have a software library where we have a chassis class. So if you go to this bottom one right here, main documentation reference, so then if you click on data structures, data structures there, you can see you have all this stuff in the 32U for library. And if I click on chassis, then these are all the public methods that you have access to. So you can adjust the PID coefficients, but they're already set to a good default value, so you don't have to really do that. And then you can click on these and get more information about what they do. So, if you create a chassis object and then use the idle method, then that basically turns the motors off, so it would coast. If you wanted the wheels to lock in place, then you would use set speeds. So set wheel speeds, that sets the speeds in centimeters per second. So, and the first one is the left speed, and the second one is the right speed. And that will try to, supply as much, it will adjust actually the duty cycle to the motors, which is the same as adjusting the voltage, to try and maintain that speed. So obviously if you're heading up a hill, you're going to require more voltage than if you're heading down the hill. But if you set this to 0,0, that's basically going to have the same effect as of locking up the wheels, trying to hold the wheels in place. Okay, and then you can see that there's pretty much everything you need in terms of the chassis. The drive system, you can set the wheel speeds, you can set the twist, right? If I look at more on that, you can see that the arguments for that one, the first one is the forward speed, and you can set that speed. That's going to be in centimeters per second, and then the target speed rate is degrees per second. So this would be especially good for using with line following, because you could just put your error in as the turning speed, right? If the error is 0, in other words, you're right, you just want to go straight, you're on the line, you want to just keep going straight, then you want to, your turning speed would be 0 degrees per second. And then if it's positive, you want to go one way. If it's negative, you want to go the other way. So that would be useful for line following with, basically using proportional control. You can also drive for, right? So this one, you can see that you want to say you want to drive for 20 centimeters, and there's 3 arguments there. So you have one is the distance that you want to go, the other is how fast you want to go. So obviously that has some algorithm that's figuring out, well, when you call that command, you can't instantly be going that speed. And when you reach the target distance, you have to start to slow down. Otherwise, you'll go past it. And then it has true, you can say true or false. If it's true, then the function blocks until the motion is complete. So this is similar to what you did with the VEX V5, where you had a true or false, whether it was blocking or not. If it's false, then it doesn't block. It just the microcontroller will continue to monitor that, the distance and the speed, and try and get you where you're supposed to go. But you'll go on. You'll be able to go on to the next code. It's not going to wait until you get there to go on to the next line of code. Okay, and then you have turn for. So this would be a turn in place, right? Target angle to turn in degrees, and then you could also give it how fast you want to turn, the target speed rate in degrees per second. So that's the same as that previous one we looked at, which was drive for, except this one is turn for. And then you can check to see if the motion is complete, if you've gotten there or not. That's for use with either drive for or turn for. And so anyways, you have pretty much everything you need already in terms of the chassis. Obviously, you're going to be building other stuff on top of the chassis that you're going to have to write your own code to control. But the chassis is pretty much done in that way. So what we have to do then is we want to instantiate an object using this chassis class. Okay, so I've filled in a few things in the main.cpp now. So we still have the include Romi 32u4.h, but Professor Lewin has created again this this chassis class, and so we need to say include chassis.h to get the header file. And then we have to instantiate it. So the class is capital chassis. And most of the time when you have a class, you can choose whatever name you want for the object. But in this case, you have to choose this lowercase chassis. You only have one chassis, so that's not a problem. And then under setup, I think we had already put in the serial.begin. So we could print to the terminal here. And then you also want to say now chassis.init to initialize the object. Okay, and then in loop, I put in just a serial.print line, prints whatever you have in this parentheses here, and then moves to the next line. And then just delay 2 seconds, and then it'll set the motor efforts to 100. Remember, if you hover over this, you can see that it shows you, you can set the motor efforts, the maximum effort. So full voltage, 100% duty cycle would be if you put in a number 420. So I just put in 100 each for the left and the right. And then delay, and then I want to stop. So I just set the speeds to 0, delay another 2 seconds, and then put them in reverse, delay 2 seconds, stop, and then stop the motors, and then print hello world again. So we'll see if this will build now. So I just click on the check mark, and I've actually already tried to build this once, so it's already been through once. But the first time you do it, it might take a while. It's importing all the libraries or whatever, and it usually takes a few minutes. Actually, this is taking a few minutes now, so maybe this is a good example. And I can move this up a little bit so to see a little bit more what's going on. So yeah, so the first time you build, it takes a little bit of time. Okay, and it looks like everything is all right. So it says success, took 35 seconds. Wow. All right, so now we want to upload it to the Romi itself. So use the right arrow to do that, and just have to plug Romi in. And so I'll go ahead and okay, so you may be able to hear it running. I'm going to, yeah, let's see. I didn't have enough USB points. I got to get a USB hub, but you can probably hear it, and then it goes back and forth, and then prints hello world again. So I'm just going to got to get my camera set up again. I have to switch out some USB port cables here, and I have to switch to the laptop mic. So hold on just one. Okay, so there's the Romi running, and I think what I'll do now is let's go back to the program, and it's supposed to be able to go up to 420. So let's see what happens if at least change it in one direction to 420. And we'll load it again. Okay, there we go. So it still goes, it's set at 100 in one direction, and then it's one screaming little Romi bot when it's set to 420. So probably don't want to try any code with initially the motor effort set that high. By the way, it's kind of strange with the Romi. You turn the power off, and then you still have to push down the power button to actually stop it. But let's see. So, anyways, I think that gives you at least the beginning of doing your first project. And as you can see, that the library for the chassis has pretty much everything you need for driving around. So, anyways, hope you found this helpful.